This video is going to be all our notes for Lesson 5. This is all about solving these rational equations and expressions that we've been working with now. So we briefly went over cross multiplication if you were in class. So that's the first key point here, solving using cross multiplication. And then we'll also look at using that least common denominator. So these are two ways of solving. That's what the key points say. It's like saying, hey, you can solve using this, hey, you can solve using that. So example 1 says, if you're solving with cross multiplication, what you're going to do here is you're just going to say, okay, this numerator on the left-hand side of my equation is actually just multiplying by my denominator down here, and this denominator is multiplying by my numerator over here. So that's going to create an equation for us, and that's going to look like a 3 times 4x plus 5, and that's equal to a 9 times an x plus 1. From here, you're just solving like regular. So I would go in and I would say, okay, this 3, it's going to distribute here. This 9 distributes here. So my overall equation looks like a 12x plus 15 is equal to a 9x plus 9. Now I just want my x on one side and my constants on the other, so I can keep it positive on my constants. On my variable, I'm going to bring the 9 over to the other side. Minus 9x minus 9x. If you had decided to bring the 12 over to here, remember that's still the same thing, you're going to find the same answer. This cancels, and then I want the 15 on the right side, so subtract 15 here. That cancels there. So I end up with a 3x is equal to negative 6. Divide by that 3 on both sides. Cancels out here, so I have an x is equal to a negative 2. With the practice, you're doing this exact same process. The only one that works a little differently is question 3. So 1 and 2 will work out the same. You'll end up with linear functions equal to each other. But with 3, we're going to end up with a quadratic. So just to review that with you guys, when I cross multiply here, I have an x on the top and x in my denominator here. So when I cross multiply here, I'm going to end up with a 2x squared plus 5x, because I'm distributing that x to both terms, equals to an 11x plus 8. Now, we've learned a couple ways of solving quadratics. We've said, hey, I can isolate my x squared and do a square root, but we can only do that if x squared is the only variable in there. As soon as I see this 5x and 11x, I can no longer do that option. So then that leaves us with factoring or quadratic equation. But both of those strategies say, hey, you need this equal to 0. So that's going to be our first step of solving here, is getting this equal to 0. So I'm going to subtract 11x from both sides. I'm also going to subtract that 8 from both sides. That leaves me with a 2x squared minus 6x minus 8 is equal to 0. Now, 2, 6, and 8 are all even numbers, so I can divide those all by 2. So if I divide that by 2, that's just 1x squared left, minus a 3x minus 4 equals 0. From here, we're factoring. We're using that t-chart. So we're saying, hey, what multiplies to negative 4 but adds to negative 3? Well, negative 4 times 1 gets me negative 4. And if I have a negative 4 plus 1, that gets me negative 3. So my factors in this case are going to be an x minus 4 times an x plus 1 equals 0. What I do now is I take each of those factors and set them equal to 0. I have an x plus 1 equals 0. So that means x equals negative 1. And then for the other one, x minus 4 equals 0. Well, x equals a positive 4. So we would have 2 solutions for this one. Now, I recommend pausing the video here, going and completing those other 2 practice problems, and then I'm going to move forward in the notes. So this is the solving using the least common denominator. So with this one, it's a little trickier just because you have to say, okay, what is in my denominators? What do I need to multiply to get it so I only have numbers on the top? I don't want anything in my denominator. So what I'm noticing is this x that is on both sides, and then there's a 4 here. So what I'm going to do is, in order to get rid of that 4, I need to multiply both sides by 4. And then to get rid of that x, well, I also need to multiply both sides by x. Because my lowest common denominator is a 4x. So when I multiply that here, the x on this one is going to cancel out when we're distributing this. So I'll have a 5 times a 4 left over. So we end up with a 20 from my first term. Plus, well, the 4's cancel for this one, but an x is up behind, so a 7x. Here, the x's cancel, leaving me a 4 times 9, so a negative 36. Next step, subtract 20 from both sides. I end up with a 7x is equal to a negative 56. Here we divide both sides by the 7. Get our final answer. X is going to be equal to 8 here. So then for B, looking at this, same process. I'm going to say, okay, this side has just an x, so I need to multiply x on both sides times x. And then this side has that x minus 5, so I need to multiply both sides by the x minus 5. So when I distribute this here, because remember I need to multiply it by each of my terms, when I multiply by 1, well, it just comes back out. I have an x times an x minus 5, and I would keep them factored for now. Then, when I distribute here, the x minus 5's cancel, but the x is left behind, so I have a minus 8x is equal to, here, the x's cancel, a 3 times an x minus 5. So now that I'm here, I'm going to say, okay, didn't work out nicely. I'm going to need to expand these and combine terms and solve like a quadratic. So first step is to distribute here and to distribute here. So we'll have x squared minus 5x minus 8x is equal to a 3x minus 15. So what we need to do is bring this 3x over, because remember, our first thing says, hey, we need this equal to 0. So I have another minus 3x, and I have a plus 15 on both sides. Cancel, it's going to be all equal to 0. I'm going to have that x squared still. Now I need to take all 3 of these like terms that have the x on it and add them together. We are going to end up with a negative 16x, and then we have the plus 15. So now I'm saying, okay, t-chart, what multiplies to 15 but adds to a negative 16? Well, I know 15 times 1 gets me to 16, or sorry, would add to 16. But if I need it negative, these would both be negative then. Because a negative 15 minus 1, well, that is the negative 16 we needed. So over here, our factors, we're going to have, okay, x minus 15 times an x minus 1 equals 0. So solutions, x is 15 and x equals 1. So factoring is really something you just need to know how to do by heart. You will use it forever and ever in any math class in order to solve. For C, this one's a bit trickier just because that x squared minus 9 on the bottom. The trick to this is recognizing still that that is the a squared minus b squared. You need to also know this one by heart. Whenever you see that, you need to say, hey, what is the square root of 9? Well, the square root of 9 is 3. So really what this is an x plus 3 times an x minus 3 in my denominator here. So then if I'm doing my like terms, I see, okay, there's an x plus 3 here and here. So I need to multiply both sides by x plus 3. And I'm multiplying this side by x plus 3 here. Next I'm saying, okay, well there's also this x minus 3 on both sides. So I need to multiply by an x minus 3. So when I distribute that here, the x minus 3's on this side will cancel. So I'll have 6 times the x plus 3 is equal to the x plus 3's here cancel, so this one goes away. And the x minus 3 is going to cancel. That one's going to go away. So we have an 8x squared then, minus, well I have a 4x, times, this one cancels, but I still haven't multiplied the x minus 3. That is going to come over. Next step, I'm going to be distributing here. So we are going to have a 6x plus 3 is equal to an 8x squared minus 4x squared minus 12x. First step, get this equal to 0. So what I'm going to do here is I'm going to subtract this 6x to the other side, and I'm going to subtract the 3. Cancels, 0 is going to be equal to, well I can combine my like terms here, so I have 2 terms with an x squared on it. Those can combine here. I have a 4x squared then. Next I have the terms with x on it. That's going to be a negative 18x minus 3. What am I doing? Not 3. This is 18. So minus 18 minus 18. Forgot to distribute the 6 here. Distribute the 6, this should be an 18 then, meaning I'm subtracting an 18 over here. So minus 18. Another mistake. Okay. This should also be a plus 12x. That's what I did. So I'm just going to rewrite this down below then. Because of the negatives times the negative here, it's going to be a positive 12x. So we should have 0 is equal to still 4x squared, but it's plus 6x minus 18. So here, t-chart, in order to factor this, is going to be needed. First thing I'm going to do though is say, okay, these are all even numbers. I can divide them by 2 because that's going to make our numbers a little bit nicer. So I'm just saying, okay, if I divide all this by 2, I'll have 0 is equal to a 2x squared plus 3x minus 9. So now when I do my t-chart, I'm going to say, okay, this one has this number out front, so we have to do factoring by grouping. So now I'm saying, hey, what multiplies to a negative 18 but adds to a positive 3? Well, 6 times a negative 3 gives me negative 18, and a 6 minus 3 is a positive 3. So that's just telling me how this 3x actually breaks up. So we're going to have 0 still. That's going to be equal to a 2x squared plus 6x minus 3x minus 9. Now I need to go through and I need to say, hey, what do these terms have in common and what do these two terms have in common? Because I am going to group these together and I'm going to group these together and then pretend there's still a plus sign in between. So these are both even numbers, so I can have a 2 come out front. And they both have an x, so an x can come out front. So I'm just doing the opposite of my distributive property. If I divide this by 2 and x is left behind here, and a 3 is left behind here. With this one, they both have a 3, and they're both negative. So a negative 3 can come out, and on this inside, an x plus 3 will be left behind again. If you want to check this, you can just say, hey, if I distribute this, will I be back where I was before? Now, still equal to 0, so my final factors are going to be that x plus 3, and then I'm going to have that 2x and the minus 3 making up my other factor. Those are both going to be equal to 0, so if I solve them for 0 here, our final answer is going to be, okay, a negative 3 here, and a 3 halves. I'm just solving each of these factors for 0. So I know these can be a little tedious, a lot of work, but we still need to know them. We will have this on our unit test on Wednesday next week. There are 4 practice problems. You should pause and complete those now. You must complete at least 2 of them. If you have all 5 completed, I will give you +3 on the homework for lesson 8.5. Last thing we're going to do is we're going to look at inverse functions again. So we're going to find the inverse of some of these rational expressions. So what I want to do with this one is I'm going to say we can check if these actually have inverses. And then that's going to be this first part to determine whether it's inverse, and then I'm going to actually find it. So just to determine whether it's inverse, I'm just going to think about the shape of these rational equations. When they're like this, it's just a hyperbola graph with these 2 branches. And we're going to say, hey, if I want to know whether their inverse exists, we have to do that horizontal line test. If I draw horizontal lines here, they should only pass through one point on my graph if my inverse is an actual function. Well, I can draw a couple testers in here to visualize, but nowhere that I draw this will it ever actually go through 2 points. So what I can do is go in and say, okay, how do I find my inverse here? So now we're finding f inverse of x. So what I have to do first, my bad. What I have to do first is switch the variables. So where I see f of x, that's technically a y value. So what I'm going to do is I'm going to write x instead. Next I have a 2 divided by x plus 3. And instead of writing x, I'm going to write y. Now I just have to rewrite this so that I have solved for y. If you want, you can think about this as cross multiplication by saying, hey, this is over 1, I'm going to have a 1 times 2 and an x times a y plus 3. Or you can just say, hey, I'm going to multiply both sides by y plus 3 times a y plus 3. And that's going to help me get this out of the bottom because here we'll cancel now. So I have x times y plus 3 is equal to 2. So now I'm like, hey, there's this x here. I need to get rid of it if I'm going to isolate my y. Divide by x on both sides. So then I have my y plus 3 is equal to a 2 divided by x. Last step, subtract the 3 from both sides. Make sure you keep that minus 3 on the outside. It's not going to jump into the denominator or the numerator here. Final thing, we write this in our inverse function form, function notation form. F inverse of x is equal to a 2 divided by x minus 3. So there are 2 practice problems to the right here. You need to have these done. If you have any questions, as always, feel free to email me. And don't forget, I need those corrections sent to me by tonight at midnight, Saturday, or else I'm not taking them because I need to get those grades in because grades are due next week. I think that is it. Have a wonderful rest of your weekend. Hopefully this is the last thing you had to do. And yeah, I'll see you guys on Monday.